Hello, everyone. Hopefully, you guys are all doing okay. Today, welcome to section 1.3, which is functions and relations. So, we begin by defining what is a relation and a function. So, relations are a set of ordered pairs, x and y. There exists a relationship between x and y. So, for example, if I have 1, 2, when x is 1, here y is 2. There exists a relationship between x and y. And then you have the set of x values in ordered pairs is called the domain. So this is x values. Let's highlight that. So the x values are your domains. And your y values in the ordered pairs are called the range of the relation. And this will always be the case. Now, what's the difference between a relation and a function? Well, given a relation x and y, we say that y is a function of x if this is key. For each value of x, there is exactly one y. So assuming that we have an x and y, so this is saying 2 goes to 1 and then 2 goes to 3. Well, 2 goes to 1 and then 2 goes to 3. So notice that these are two different y values, so this would not be a function of y. So we'll say that y is not a function of x. So what if I have a 2 and a 1, and then a 3 and a 1? Okay, well, 2 goes to 1 and 3 goes to 1. This is x, this is y. That's fair because the 2 and 3 are different x values. So they can still go to the same y as long as they're not the same x value. All right, so then let's determine if the relationship defines a function of x. So the first thing we want to do is write it as the eighths. So 2, so this is x, this is x, this is x, that's my domain. So 2 is a domain, and 3 is a domain. Now my range are my y values. So let me use a different color. This is x, and then y are going to be my peak. So it's going to be 3, 4, 5. So the first order pair says x, y, 2, 3. And then this one says 2, 4. And this one says 3, 5. What do we see? That 2 goes to both 3 and 4 simultaneously. This is not a function of x because 2 has 2 different y values. It's not allowed. Now, similarly, 1, 2, and 3. Now I'm looking at the next example. These are my x values. That's my domain. And my range are 3, just 3, and then 5. So we're going to do some arrows. 1 goes to 3, 2 goes to 3, and 3 goes to 5. Is that allowed? Is this a function? Yeah, because these are two different x's. That is a function. And then the last piece that looks already like an egg, you say, well, -2 goes to -2. Okay, that's good. 6 goes to 6. They all have 1 to go to, even though they're the same. So notice that your x and y are the same. That's okay. This is a yes, a function. Because no same x goes to different y's. Now, what happens if you have them as functions like this? Well, how do we know that this is a function of x? Well, so you have a unique x for each y. So this is a line that they're individual. So if I plug in a 0, I get a different y value. So your x's will not have, if you include the same x, you will not get two answers because you can easily solve for y. You can identify what y is easily. Now this one, you have y equal 2x squared plus 6. What happens when 2 So 2, this is another way would be, I know that this is a line. It passes the vertical line test. It only hits once. This one, we've learned that this was going to be a parabola at 6. We know the way that this graph looks like. So at 6, so then this is also going to pass the vertical line test. So this is yes function. Now, what about this one? So if we solve for y, we can just bring the y over. So we get y equals 7 minus x. This is also a line. So this passes the vertical line test, meaning that if you go vertically, it only touches once. So this is a function. Okay, similarly here, well, what about this one? What happens if we solve for y? Notice that if I have x, if I bring the, let's say the 7 over, or the y over, we'll get y squared equals 7 minus x. And then notice that this is a square, so we take the square root of both sides. So this is y equals plus or minus the square root of 7 minus x. And what did we learn from here? You'll have that this same x gives you a plus and a minus. So then, meaning that this is going to look something, of course, that does not pass the vertical line test. Because we have this plus or minus on the y, so that means that if you put an x value there, it doesn't matter. You'll get two different answers, a plus and a minus. So then you'll say no. So for example, you'll get two different values. So let's say I say x to be equal to -2. So if I include that, that's a plus or minus 7 plus 2, because 2 minuses give me a plus. This is plus or minus 3. So that's saying that -2 will give me the 3, but also a -3. So -2 can't go to -3 and to +3 at the same time. So this is not a function. Now this one, if you solve for y, you'll get y equal 7 minus x. And then this is the cube root. So the cube root, excuse me, when you take the cube root of both sides, you'll have y equal the cube root of 7 minus x. And remember, when you're a cubic, a cube, it looks like a snake, that's this. And this is yes, it passes the vertical line test. This is a function. So you won't have a plus or minus. So we're good to go. Okay. So that defines a function. So a graph defines by a function of x if no vertical line intersects the graph more than once. So here, this one, a circle, it's not a function of x because it does not, it fails the vertical line test. So VLT, the vertical line test, that it fails the vertical line test. But this one, if we pick a line, this one is okay. So yes, it's a function of x for the same reason. This one, so if we're looking at, so let's say here, what do we notice about if this is a function or not? Well, we know this is in pieces, so this is okay. But what about at this point? they're saying that at x being 0, you are both 0, 5, and then you're also 0, 1, negative 1. Sorry, 0, negative 5, and 0, negative 1. Well, 0 is already assigned to one of them, one or the other. So this is not a function because it breaks. So you're saying 0 can't go to two different places at the same time. It goes only one to the other. So right here, it fails the vertical line test. Okay. So that defines a function. Now that we know what a function is, we're ready to evaluate. So this one is a function that we're given, and these are the numbers that we want to substitute. So since this one is f of x is equal to the variable 2x squared plus, minus 3x plus 1, the inside tells me that now x is going to be negative 3. So wherever I see an x on my function, it's now going to be negative 3. So it's going to be, okay, f of negative 3 is equal to 2 times negative 3 squared minus 3 times negative 3 plus 1. Okay. And then we clean it up. The inside is 2 times now 9 because negative 3 times negative 3 is 9. And then, of course, negative 3 plus 9, and then a plus 1. So then here is an 18 plus 10, 28. This is f of negative 3. And that is our answer. Our solution is 28. Now for letter B, same idea. Now they're saying that my new x value is equal to the square root of 2. And that's okay, and if it's irrational, we can still substitute. So we'll have f of the square root of 2 is going to be equal to 2 times the square root of 2 squared minus 3 times minus 3 times the square root of 2 plus 1. Now, here we'll have 2 times, well, what's the square root of 2 times the square root of 2? When you have two radicals, they cancel out. We get the square root of 4 is equal to 2. So that goes in here, minus 3 root 2. There's nothing you can do there. And then plus 1. So you bring it down, and you're going to get 4 minus 3 root 2 plus 1. The only thing you're left to combine are the numbers that do not have a root. So that's 4 plus 1, that's a 5, minus 3 root 2. And that is our answer. This is f of root 2. Okay, so this is our solution. It looks like that. That's really nice. So let me rewrite that right here. Erase this part. Okay. So that's b, 5 minus root 3 root 2. Now what about f of a? Well, we know that x is equal to whatever's inside. So now everywhere I see an x, it's going to be now the uppercase a. So this will be 2 times now a squared minus 3 times a plus 1. And that's it. You can't do anything else. You're just substituting a into the function. Now D is a little bit complicated because we are going to be substituting wherever we see an x. We're going to plug in 3 plus z. So using a different color. Let me go with the blue. Let me go with the purple. So now x is going to be 3 plus z. So f of 3 plus z is going to be equal to 2 times 3 plus z, the whole thing squared, minus 3 times 3 plus z plus 1. Now I'm going to go slow because I need to take care of this first. So what's 3 plus z times 3 plus z? We know how to multiply binomials. 3 times 3 is 9. 3 times z is plus 3z. Plus another 3z. And then z times z is z squared. So I'm just going to clean that up. 9 plus 6z plus z squared. All that has a coefficient of 2 from this 2 from the original is equal to 18 plus 12z. I'm distributing this 9. Oh, sorry, this 2 plus 2z squared. And now I'm just going to bring this down. So this negative 3 will distribute minus 9 minus 3z plus 1. We just want to carry over. Plus 1. So now I have to combine my terms. So I have a 2z squared right there. And then I have 12z minus 3z. That's a plus 9z. And then I have 18 minus 9 plus 1. 18 minus 9 is a 9, plus 1 is a plus 10. So this is exactly f of 3 plus z. Okay, so just let me do a little recap. So we begin by substituting 3 plus z, and everywhere we see an x, we went ahead and did the binomial product of 3 plus z squared. 3 plus z times 3 plus z. There it is, 9 plus 6z plus z squared. There is a 2 from the original equation, the original function. So we have to distribute the 2 everywhere. So 2 times 9 is 18. 2 times 6 z is 12z. 2 times z squared, it's a plus 2z squared. Then we work on this side. There was a minus 3, negative 9. There was a minus 3z. And then the plus 1. I went ahead and combined in like terms. So then the only z squared, and I want to write it in descending order. The 2z squared, and then there's a 12z, and the minus 3z, that's a 9z, and then 18 minus 9 is a 9, and the plus 1 is a plus 10. So all of this is my solution. There's nothing else I can do. Okay. So that is substitution. So we're going to do the same thing with the next one. Okay. So hopefully you guys are getting there. So we're going to do exactly the same thing with the different function g. So let's begin by evaluating it at g3. So then x is equal to 3. So then you'll say, well, g of 3 is equal to the square root of 6 minus 2 times 3. So that's equal to the square root of 6 minus 6, which is the square root of 0. But the square root of 0 is 0. So then g of 3 is equal to 0. And 0 is my answer. Similarly, g of 4, it's going to be equal to the square root of 6 minus 2 times 4. So that's g equal to the square root of 6 minus 8. So then you'll have g equal to the square root of a negative 2, which is not defined. It wouldn't exist because you're not allowed to have a negative inside a root. So it would not be defined. Now what happens if g is equal to negative 4? So now you're substituting 6 minus 2 times a negative 4. It's going to be equal to the square root of 6. Now it's going to be a plus 8 because negative 2, negative 4 gives you a positive 8. So then this would be equal to the square root of 14. And that would be your answer because you can't simplify the square root of 14. This would be 2 times 7, which both of them are prime, and therefore you cannot evaluate it. Or simplified, if you will. Now, what about g being equal to, g of w, 2w? That means that now x is equal to 2w. So g of 2w is equal to the square root of 6 minus 2 times 2w. So g of 2w is equal to, notice how I carry my notation, 6 minus 4w, and that's it. So your answer would be the square root of 6 minus 4w. You couldn't do anything else. Okay. So there we have it. Now, when we're finding the x and y intercepts, there is a way to do that. So to find the x-intercepts, we want to let y equal to 0 or f of x equal to 0. They mean the same thing. Okay, and when you're wanting to find the y-intercept, you let x be equal to 0 or whatever value it is. Okay, so we let, we're finding f of 0. So then if we want to find the x-intercept, we let f of x equal 0. So then we have 0 equal to x squared minus 4, and we solve. You can either factor as a difference of squares, or you can solve for x. So I'm actually going to factor as x minus 2, x plus 2, using difference of squares. Okay, which we should all know how to factor here. And if you do not, please email me or therefore go to tutoring, and I'm happy to help. To refresh your memories, so then I have x minus 2 equals 0, x plus 2 equals 0. So I will have x equal 2, and then x equals negative 2. So that means that I have two x-intercepts at 2, 0 and negative 2, 0. That's for just x-intercepts. What about y-intercepts? I let x equals 0 on the function, so then f of 0 is equal to 0 squared minus 4. So f of 0 is negative 4. So my y-intercept, there's only one, is at 0, negative 4. And those are my solutions. Negative 2, 2, 2, 0, and 0, negative 4. Okay. So let's move on to the next one. Hopefully we're getting the gist of this. Same thing. Now we want to find the x-intercepts. We let g of x be equal to 0, the function. So we have 0 equals 3 minus the absolute value of x. And then if we want to solve for the absolute value, we have the absolute value of x equals 3. So what can my inside be? The inside of this function. Well, what could it be? So this is saying that the distance away from 0 is a positive 3. So then x can be equal to 3 or negative 3. So again, we will have two different values for x. The distance away from 0. So I get 3, 0, and negative 3, 0. Now the y-intercept would be g of 0 is equal to 3 minus the absolute value of 0. G of 0 is equal to 3. So then the y-intercept would be at 0, 3. Okay. So it's important for us to understand the definitions of each. So that's my x or y-intercept, and these are my x-intercepts. Okay. So I have two x-intercepts here. And then the last one, very similar. To find the y-intercept. Now I'm starting with the y-intercept. You have h of 0 to be equal to 2 minus the square root of 0. So h of 0 is just 2. So it's 0, comma 2. And that is my y-intercept. Y-intercepts are usually easier. So then my x-intercept will be h of 0. Sorry. So we're going to let this be 0. So we'll have 0. So we'll have h of x being 0. So 0 equals 2 minus the square root of x. Bring the x over as a positive root x equal 2. Now for this one, we'll say, well, we'll square both sides to undo the square root. So x is going to be 4. So my x-intercept is at 4, 0. And there's only one. So that's my x-intercept, and there's my y-intercept for those 3 examples. Okay, so hopefully you guys are paying attention, identifying how to easily identify x and y intercepts. All right, so then we are going to move on to the next experiment of this section. And we're going to go back to remembering what this a relationship means. So we talked about the domain, excuse me, not that one. The domain is going to be all the values of x. So the domain are all the x values in a function. And then let me highlight that. And then here I'll have the range are all the y values in a function. So for example, if we look at the first example, remember what is my x values? My x values are all these. So this is negative infinity and this is positive infinity. So notice that my graph begins all the way to the left. So my left and it goes all the way to the right side. So my domain is negative infinity to positive infinity. And my range is the lowest point to the highest point. So the lowest point is 1, 2, the point 2 right here because this is 0, 2 to infinity. So the lowest point is 2 on my range. My range is my y value 2, and it's going to go all the way to infinity. Okay? Now, this is a nice smooth graph. 18 is different because 18 is split. So we're going to have 2 different values. So if we look at our x's, it begins all the way to your left. So it's going to be negative infinity, but it stops where? At 0. And 0 has an open dot at this value, but then it resumes up here. So then at negative 1. So far, the open circle means it's open, and then you have a continuation. So you have a union. That means you have a break. So your union says you're going to pick up your graph again at a bracket because you have a closed dot at negative 1, and then you go all the way to the right side. Excuse me. All the way to the right side, which is a positive infinity. So notice how this one's different because this one's nice and smooth. There's no holes, there's no breaks. But this one, you're starting all the way so left to right, but then this is a open dot at your x value being what? What is your x value? 0, and then so it's open. So it's going to come back. You're going to have a continuation at negative 1, x being negative 1, all the way to positive infinity. Now your range is a little bit different because your range is your lowest point to the highest point. So you'll say, okay, well, the lowest point is this one, and my highest point is this one, right? but we have to look at the whole graph. So then in this case, what my range is going to look like. So then what we say is that our lowest point was here, the value of -10. So the -10 is included, so it's -10 all the way to infinity. So infinities will always have an open parentheses because they're not bounded, meaning that it's not a finite number, it goes on forever. So then your range is -10 to infinity. So in this one, the lowest point is actually here if we look at the whole graph. So -10 all the way to infinity. So the domain we're looking at left and right, the range down up. Okay, so moving on to this one. Similarly, the domain starts right here at -infinity, but it stops. So if we have, so it's going to go from -infinity to +1. But then at 1, it also has a gap. 1, 2. And then it's going to go all the way to the point 4. So therefore, my domain is going to go from -infinity to +4. And it stops right there and it has a closed dot. So the difference between 19 and 18 is that here my x's were open and closed, okay? But here, my x value stayed the same. Okay, so my x had -infinity, so then there's this gap. But now see how this one's a closed dot and an open dot, but it's still at 1, it's at a different value. So then here we have from -infinity to 4. The difference is on my y value, my range. Now range here, this is an open dot, so the lowest point is at 1. And then it jumps to +1. I'm sorry, it jumps to 2. So that's different. So see how the 1 is just going to be by itself, and then union 2 to 8. Excuse me. 2 to 8, because it's a different. So when it's an open dot, but it doesn't have anything else, right? My y value, the lowest y value is a y, then it jumps to 2 from 2 to 8. Remember, I'm looking at the y value. So that is the domain and the range. So you need to be very careful whenever you have gaps like this. This is called a piecewise function that we are also going to go over in this class. So what about this one? Well, my starting point is at, so see how this one looks a little bit different because of the way that it is. But be careful, this, we're looking from my x value. So it looks like it's going down, but it's actually going to go to the right side. So on that right side, so this one's going to go on forever. So my domain starts at -2, and it's going to go on forever. But what about from bottom up? So the lowest point, see how this is, the arrow is going to go down, down to -infinity. That's what I care about for my x. So my highest, in this case, the lowest point would be -infinity, and the highest point is this peak at y being 4. And that is my range. So be very careful. The lowest point, it's going to come from -infinity and then up at 4. That is the y value, the range, the x. It's from left to right, but notice the right is still going to go onto this positive infinity, but it's going to live down here. That's okay, but you're still going to the right. And that's the range and the domain. So here it is. Now that we have this pieces, this is the last view, and this is exactly a piecewise function. So they're saying use the graph of y equal f of x to answer the following. So the first one they're saying, what happens when x is equal to -3? Well, what happens when x equals -3? You see 2 points. So which one is it? It's actually going to say, well, at x being -3, the only one that is actually defined is at negative. So sorry, when x equals -3, you're going to go 1, 2, 3, and that's this point, -3, 3. So your solution is actually -3. So you're going to your x value, excuse me, what happens when x is -3. So you're going to go to your graph 1, 2, 3, and then you're going to look at the one down here, and that corresponds to -3 on the y. What about f of 0? Well, f of 0, that means our x is 0. So what happens when x is 0? It corresponds to which number right here? 0, 2. So your 0, 2, that's where it exists. And then you'll have find all x values for which f of x equals -1. So when x is -1, this is saying that your y value is -1. So you're going to go to -1 right here, and you're going to say, well, which values? So you can say, okay, well, I have a value here and a value there. And then when you look at the two corresponding values, you'll say, okay, well, it only exists at -1 when x is -1, because that's when the dot is closed. The other one, it does not exist at that region. It's an open dot. So if you would say +1, that's not true because it's an open dot. Now, what happens when y is equal to +1? So when y is 1, right here, your value corresponds to 1, 2, 3. So when your y value is 1, so we'll have this, excuse me, when f of x equals 1, it's this equation, and you'll have y equals 1 at how many places? So right here, that's where it clicks, because remember, an open dot does not exist. So your only function would be at x equal 2, because that's when it's closed. See how it's touching that function right there? So y equals 1 and y equals -1. So this is y equal 1. And then here you have y equal -1. So then y equal -1, that corresponds to x being -1. And when y equal 1, it corresponds to the point x equal 2 because it's closed. And they're saying determine the x-intercept. Well, when is it touching the x-intercept? It doesn't. So be careful. So there's no way where it's touching your intercept, your x. So this is your x-intercept. Your graph is not touching it. So there's no x-intercept. What about the y-intercept right here? The green. Where is it touching it? Right here at the point 1, 2. So 0, 2. we do have an intercept. And then the domain, remember, it's left to right. So the domain is from the left side. So negative infinity to the left to right. So it's the whole shebang. Negative infinity to positive infinity. Now your range is different, your lowest point to the highest point. So notice that it's coming already from negative infinity. And then it stops at what? At what value? At positive 1. And then it's a closed dot because it's a closed dot, and then it's a union. And then it starts now at positive 1, open dot. So then there's the parenthesis right there. 1 to infinity. So then right here, it starts again at 1, and then it goes to infinity. So here we have to be very careful because I have an open dot and a closed dot. So the continuation would be the closed dot. So sorry, this is a negative one. So it's going to be, let's look at this one. So it's negative infinity and negative 1. And then it picks it up at y being a positive 1. So you have a closed dot and an open dot. So the closed dot wins. So it's a closed bracket, 1 to infinity. Okay, let's look at that again. So this became a closed dot bracket because of this closed dot 1 at y being 1, 1 to infinity. So again, refreshing your memory, and we're going to do an activity. There's going to be a Canvas activity of piecewise. So there was only one example, but I feel that that's not enough. Okay, because you're going to see that sometimes, and then you're going to do some practice graphing this. Because here, notice that this is a closed and open. So this technically, it's not defined because you have an open dot. It's not continuous. But then there's a jump into discontinuity, and you'll learn that when you get to calculus. So basically what I'm saying is one is a closed and one is open. In this case, we had to make a decision on the y value. So we have an open dot and a closed dot. But notice how our graph goes from 1 to infinity. So then this part of our range is 1 to infinity with a closed bracket. It's a closed bracket at 1 to infinity because we're looking at the range of the whole function. And then again, please be mindful that there's going to be a Canvas activity or piecewise functions. It might be a Desmos activity. It might be a worksheet. It might be a Kudos worksheet for practicing. So please stay tuned on how to do an extra practice. All right, I will see you guys next time. Bye-bye.